Hi everyone, let's cut through the noise. In 3 minutes, I'll show you exactly when you must use an isolated power converter and when you're better off without it. Let's go. An isolated converter uses a transformer for magnetic coupling. Its greatest feature? Zero direct DC connection between input and output. They have separate, independent grounds. This physically breaks any conductive path. A non-isolated converter uses an inductor and shares a common ground. It's simpler, cheaper, but it has no physical safety barrier. If you don't need isolation, use the classic buck step down or boost step up topologies shown in Figure 3. If you do need isolation, you'll choose between the two kings in Figure 4. Flyback. The transformer stores energy. It releases it when the switch is off. Great for low-cost, sub-100W designs. Forward. Energy transfers directly to the output while the switch is on. Better for higher currents. How do you choose? Refer to Figure 5 and Figure 6. Ask yourself two simple questions. Question 1. Do you have safety regulations? Connecting to AC mains or medical human contact applications? Yes equals isolation is mandatory. Question 2. Do you have different ground domains? In industrial setups, distance sensors have different ground potentials, creating ground loops that cause noise. Yes equals use isolation. If both answers are no, you're safe within a single DC domain. Pick non-isolated. It's smaller, cheaper, and more efficient. Look at Figure 7. Stage 1. An isolated AC-DC converter turns dangerous AC power into Asafi 12 volts or 24 volts DC bus. Stage 2. Multiple non-isolated pole point of load converters turn that bus into 5 volts, 3.3 volts or 1.8 for your chips. This balances safety with high efficiency. Look at the industrial example in Figure 8. Without isolation, differences in ground voltage, 0.8 volt versus 1.2V create ground loops, destroying signal integrity. Using an isolated DC-DC at each node breaks the loop completely. Isolation costs power. Check Figure 10. Non-isolated converters hit 96.2% peak efficiency, while isolated ones are only 93.2%. You lose about 3% to 5% just to the transformer. This affects your PCB too, shown in Figure 11. Isolated designs require a physical creepage and clearance gap on the board. Zero copper allowed across the barrier. Non-isolated layouts just focus on shrinking the high current loop to reduce EMI. Final rule of thumb. If you're touching AC mains patients or differing grounds, isolate. If you're just doing simple board level DC conversion, go non-isolated to save power and space. Thanks for watching.